Have you ever wondered why we can't just hop onto the Atlas website and download breathtaking, full-color images of the cosmos like we do with the James Webb Space Telescope or Hubble? You see these incredible pictures from other observatories, but when it comes to Atlas, the story is a bit different. It's a common question, and the answer reveals the unique and vital mission of this incredible astronomical survey. So, why won't Atlas let us take its images? Well, it's not that they're being secretive. It is because Atlas was designed to be a cosmic photographer in the way we usually think of one, a TLAS, which stands for the Asteroid Terrestrial Impact Last Alert System, as a very specific and urgent job to scan the entire sky every single night, looking for anything that moves. Its primary mission is planetary defense. It's our frontline sentinel, designed to find near-Earth asteroids and comets days or even weeks before they could potentially impact our planet. Think of it less as a portrait artist and more as a high-speed security camera for the solar system. To accomplish this monumental task, ATLAS uses a system of telescopes spread across the globe in Hawaii, Chile, and South Africa. This global network allows it to monitor the whole dark sky continuously. Every 24 hours, these telescopes take thousands of exposures, covering vast swaths of the celestial sphere. But here's the key difference. It's not trying to create one perfect, deep, colorful image. Instead, it's taking quick snapshots. Each location captures the same patch of sky for times in one night, with about 15 to 30 minutes between each shot. Why do this? Because this rapid succession of images allows its software to play a cosmic game of spot the difference. The powerful computer systems behind Atlas align these for images and subtract them from each other, the billions of stars and distant galaxies, which are essentially fixed from our perspective over such a short time. Just cancel each other out and disappear. They become part of the background noise. What's left behind? Anything that has moved between the exposures. These are the potential near-Earth objects, the asteroids and comets that Atlas is built to find. This process is incredibly effective. The system automatically flags these moving dots of light as potential discoveries. It then calculates their trajectory, speed, and brightness. This data is immediately sent to the Minor Planet Center, the global clearinghouse for all asteroid observations. Other astronomers around the world can then follow up, confirm the discovery, and refine the object's orbit to determine if it poses any threat to Earth. This entire process happens with breathtaking speed. From the moment the shutter closes to the data being available to the world, it can be as little as 15 minutes. It's a race against time, and Atlas is winning it for us every single night. So, the images Atlas creates are not the kind you'd want to frame and hang on your wall. They are functional, data-rich frames designed for a machine to analyze. They are often taken in different filters, not necessarily the red, green, and blue that our eyes combine to see natural color. The primary goal is to measure brightness and position with extreme precision, not to capture aesthetic beauty. The exposures are short, usually only 30 seconds, which is just enough to detect faint objects, without being so long that the stars become overwhelming, or the fast-moving asteroids streak across the frame. Contrast this with the James Webb or Hubble space telescopes. Their missions are fundamentally different. They are designed for deep sky observation. They might stare at a single, tiny patch of sky for hours or even days, collecting faint photons from the most distant galaxies at the edge of the universe. Their instruments are built to capture exquisite detail and a wide range of wavelengths, which are then painstakingly processed by teams of specialists who assign colors to different filters. to create the stunning, awe-inspiring masterpieces we see online and in magazines. That process can take weeks or months. Atlas completes its core mission for the entire sky every single night. It's like comparing a high-speed traffic camera to a professional landscape photographer. The traffic camera's job is to capture license plates quickly and efficiently. The images are functional, maybe a bit grainy or poorly lit, but they serve their purpose perfectly. The landscape photographer, on the other hand, will wait for the perfect light, use specialized equipment, and spend hours editing to create a work of art. Both are using cameras, but their goals are worlds apart. Atlas is the traffic camera of the solar system, and its work is absolutely crucial for our safety. But that doesn't mean ATLAS's data is completely inaccessible or uninteresting. That's just not presented as pretty pictures. All the data ATLAS collects is publicly available. Astronomers and data scientists all over the world use it for a huge range of research beyond just finding asteroids. Because it's scanning the entire sky so frequently, it's an unparalleled resource for studying variable stars that change in brightness over time. It can catch supernovae, explosive deaths of massive stars, often within hours of them happening. This allows other telescopes to quickly turn their attention to these fleeting events, to study them in detail. The data from Atlas helps us understand the population of asteroids in our solar system, map the structure of our own Milky Way galaxy, and discover all sorts of transient astronomical events. It's a scientific treasure trove. You have to know how to read the treasure map, which in this case is the raw data, not a glossy photo. The images are really just massive tables of numbers, coordinates, brightness levels, and timestamps. So, the next time you hear about a new asteroid being discovered, there's a very good chance Atlas had a hand in it. It might not give us the same kind of cosmic eye candy as other telescopes, but it provides something far more valuable: peace of mind. It's our silent guardian, constantly watching the skies for danger. The reason we can't just download its images is that its images are not its final product. Its product is data, alerts, and ultimately, protection of our home planet. The beauty of Atlas isn't in colorful nebulae, in its elegant, efficient, and life-saving purpose. It's a testament to human ingenuity and our desire to understand and protect our place in the universe. And that, in its own way, is just as beautiful as a galactic portrait. Thanks for joining me on this look into the amazing work of the Atlas Survey. It's a great reminder that in science, sometimes the most important work is the one that happens quietly in the background. If you enjoyed this and want to learn more about the incredible tools we use to explore the cosmos, be sure to like this video and subscribe to the channel. We'll see you in the next one.